Welcome to my presentation this morning titled The Brain, Consciousness, and the Spiritual Mind. On the cover of its February issue this year, Scientific American called this time the New Century of the Brain. Now, while they may have used a bit of exaggeration to help sell the journal, it's clear that national and international research focus has shifted from the human genome to brain science. I've used four principal references for this presentation. Loyal Rhu's book titled Everybody's Story ties the evolution story of the universe, the earth, and human beings to the development of the mind and consciousness. Rhu's work is foundational to Michael Dowd's Thank God for Evolution, which seamlessly integrates human evolution with universal spirituality, not just Christianity, but all religions. Dr. Andrew Newberg is a brain scientist at Thomas Jefferson University in Philadelphia who wrote Why God Won't Go Away. He followed it with a Great Courses DVD, The Spiritual Brain. Newberg's focus is on neuroscience research that examines the impacts of religious experience on the brain. Finally, Michio Kaku is a theoretical physicist, one of the co-founders of string theory, and don't ask me what string theory is, who recently wrote The Future of the Mind. I borrowed liberally from these references, each of which reflects the modern views of a great many neuroscientists and theologians on the topics of this presentation. I'll begin with a quick overview of the major structures of the brain, then describe in layman's language how the various parts of the brain function and how they relate to each other. Next, I'll spend a short time on what we mean by consciousness. I'll conclude the presentation with how our minds are conditioned to respond to spiritual experiences and to various forms of religious practices, including prayer, meditation, and mysticism. Now, most laymen tend to equate the mind with the brain, and we hold the same mental image of the two. But the mind and the brain are not the same thing, and we need to get some clarity on this point. The brain is a biological organ located inside our head with electrochemical connections within it, and through the sensory and motor organs to the rest of the body. In contrast, we tend to think of the mind as the perceptions, thoughts, feelings, and experiences we have, and that these intangible qualities of the mind must be connected somehow to the biological stuff of the brain. Some scientists believe that the most striking evolutionary event since the demise of the dinosaurs has been the development of the cerebral cortex in humans, the largest and most complex part of the brain. Most of the human brain is contained in the familiar folds of the cerebral cortex. This is where all high-order cognitive functions occur, which is why it's often considered the seat of our human experience. The vast majority of the cerebral cortex is covered by the neocortex because it's the most recently evolved region of the brain. It's only about as thick as a napkin. The evolution of the new cortex gave us the intelligence that separates humans so decisively from other animals and enables us to create language, art, literature, and culture. The cerebral cortex is connected to the body by the more primitive limbic system, which may be thought of as the primary emotional controller of the brain. Then to the brainstem, which in turn connects the brain to the spinal cord and the biological processes of the body. The cerebral cortex, particularly the neocortex, is where the mind and body come together and create our self-image and our view of the world. The brain is divided into four basic lobes. The occipital lobe in the back of the brain, which controls our vision. The frontal lobe in the front part of the brain, which organizes our attention. The temporal lobe along the side of the brain, where our verbal conceptual capacities are located. And the parietal lobe toward the back top part of the brain, which provides our spatial and temporal orientation. I'll come back to these functions a little later because they're critically important in our religious experiences and our perceptions of God. What makes all these brain processes work? The basic foundational unit of the human nervous system is the neuron, the tiny spindly cell that, when arranged in intricately woven chains of long neural pathways, carry sensory impulses to and through the brain. Neurons are the liveliest of cells and are uniquely capable of becoming excited. Embedded in their patterns of excitement is information essential to the normal functioning of the person. In addition to their excitability, neurons are uniquely well structured for multiple interactions with other cells. The typical neuron will be capable of interacting with up to 1,000 other cells. Put 100 billion neurons, which is the human count, into hundreds of interactions each, and we have the potential for trillions of information events. At the basic level, sensory data enters the neural system in the forms of billions of tiny bursts of electrochemical energy gathered by countless sensors in the skin, eyes, ears, mouth, and nose. These neural impulses race along neural pathways, cascading like a line of falling dominoes, leaping synaptic gaps, and triggering the release of chemical neurotransmitters as they carry their sensory message toward the brain. Familiar names among the neurotransmitters include glutamate, dopamine, histamine, and serotonin. Once inside the brain proper, sensory information is channeled along the appropriate neural pathways, routed and rerouted to the appropriate processing areas. Here they are sorted, cross-referenced, amplified, or inhibited, integrated with input from emotional centers and other senses, and finally assembled into a perception that has a useful individual meaning to the owner of that particular brain. Our genes hold instructions for when, where, and how many neurons will be built. The genes further ordain much of the complicated neural circuitry. But as more interneuron systems were brought into play by evolution, there also emerged a potential for additional circuits to be constructed and reinforced by individual experience. Add one neuron to the brain and you add the potential for many new interactions. Add millions and the possibilities for information events multiply exponentially. In other words, as our brains became more complicated, the organizing influence of the interneuron connections came to rival the organizing influence of the genes. The ability to encode information in direct response to the environment bypasses the indirect and tedious logic of storing information in the genes. The ability to learn directly from the environment has enormous survival value. Learning is a splendid thing, but there's a point of diminishing returns to this neural learning strategy. Any neural system organized exclusively by learning would take an eternity to acquire the programming mentally required for normal functioning. Moreover, such a system would be much too slow to respond efficiently in an emergency. Fortunately, evolution has evolved a solution for maximizing the advantage of neural learning, and that solution is culture. Cultures maximize the power of learning by making its fruits heritable. What? Heritable. Cultures maximize the power of learning by making its fruits heritable. That is, you can inherit those. Humans are equipped to externalize acquired information by formulating symbols that can be decoded by other humans. The neural organization achieved by the learning of one individual can be replicated in another by the process of symbolic communication, especially symbolic language. The cerebral cortex of the human brain is divided into the left and right hemispheres, which are similar in appearance and to some extent function. The left hemisphere receives and analyzes sensations from the right side of the body, while the right hemisphere does the same for the body's left side. Both hemispheres also contain centers for processing language, which, when working in concert, give us the power of expressive verbal communication. Dr. Roger Sperry of the California Institute of Technology won the Nobel Prize in 1981 for showing that the two hemispheres of the brain are not exact carbon copies of each other, but actually perform different duties. Dr. Sperry was treating epileptics who sometimes suffer from grand mal seizures that go out of control. He began by severing the corpus callosum, a network of nerve fibers which connect the two hemispheres of the brain, so that they no longer communicated and shared information between the left and right side of the body. This usually stopped the feedback loop and the seizures, and at first, the split brain patients seemed perfectly normal. They were alert and could carry on a natural conversation as if nothing had happened. But a careful analysis of these individuals showed that something was very different about them. After detailed studies of these patients, Dr. Sperry finally concluded that there could be two distinct minds operating in a single brain. He wrote that, and I quote, "Each hemisphere is indeed a conscious system in its own right, perceiving, thinking, remembering, reasoning, and emoting, all at a characteristic human level. And both the left and right hemispheres may be conscious simultaneously in different, even in conflicting mental experiences that run in parallel. Normally, the hemispheres complement each other as thoughts move back and forth between the two. The left brain is more analytical and logical. It's where verbal skills are found, while the right brain is more holistic, artistic, and creative. But the left brain provides the neurological basis for oral and written language, and because those functions are so important in the formulation and expression of conscious thought, the left is often referred to as the dominant hemisphere. Now let's take a more general look at our brains, how they came to be, and how the different structures of the brain function together, or not. I'll use the images here from Michael Dowd's Thank God for Evolution, in which he introduces the useful concepts of day language and night language. Symbolic language is metaphorical. For our kind of intelligence, metaphors are not optional. Dowd reminds us that there are two complementary sides of the coin of our experience. On one side is the realm of what's so, the facts, the objectively real, that which is publicly and measurably true. Let's call this side of reality our day experience. We talk or write about it using day language, that is, normal, everyday discourse. The other side of our experiential coin, Dowd terms our night experience. It's communicated through night language by way of grand metaphors, poetry, and vibrant images. Our attention is focused on what does it mean? This side of our experience is subjectively real, like a nighttime dream, though not objectively real. Night language is personally or culturally meaningful. It nourishes us with spectacular images of emotional truth. This slide shows an image of the quadroon brain with its four structures termed the reptilian, old mammalian, new mammalian, and advanced. Modern understanding of the human brain offers scant evidence to suggest that a designer God engineered a perfect mental toolkit for the human endeavor. The scientific evidence is overwhelming that the human brain is an emergent phenomenon in which physical structures and neurological connections developed in an additive and exploratory way over hundreds of millions of years. To help us remember what these parts of the brain are all about, Michael Dowd introduces some night language into his description. Reptilian becomes our lizard legacy. Old mammalian is now the furry little mammal. New mammalian is our monkey mind, named already by the Buddhist because it's always chattering to itself. And the advanced becomes our higher porpoise, for reasons which will soon become clear. It's now beyond dispute in the scientific community that our deepest and most basic brain structures were shaped within the skulls of our reptilian ancestors, who ate, survived, and reproduced in an era that long preceded dinosaurs, hence the term lizard legacy. Scientific evidence indicates this part of our brain is about 500 million years old. The cerebellum and the brainstem together handle our involuntary breathing, bodily movements, and acquire muscle memory, most notably our learned ability to ride a bike, drive a car, type on a keyboard, or play a musical instrument without having to think about it. Our ancient reptilian brain is also the seat of instinctual drives that are least subject to conscious control. Dowd calls these primordial drives the 3 S's of our inherited proclivities: safety, sustenance, and sex. As with its expression in reptiles, the fight, flight, freeze response in humans is involuntary, beyond the range of conscious choice, especially in the face of sudden and unexpected danger. Our lizard legacy is also the seat of deep territorial defensiveness and aggression when our boundaries are threatened, which is why arguments and wars tend to escalate. If individuals are challenged by food, sex, drugs, and other physical addictions, it's the reptilian brain that is the deepest, though not the only, source. The old mammalian, or furry little mammal brain, is the limbic system, consisting of amygdala, hippocampus, thalamus, and hypothalamus. Reptiles don't have limbic systems, but all mammals do. It's the seat of deep emotions, and its health and well-being seem to require periodic entry into the dream state. Mammals, in fact, must dream, or they will die. In contrast, no reptile or fish appears to dream. It seems the limbic system evolved as a way to provide more nuanced behavior and experiential learning than reptiles are capable of. Only a few reptiles nurture their young post-hatching, but all mammals do, via the provision of milk and kin bonding. Emotions for familial bonding have always been crucial for mammals. For those mammals that evolve social groups, family bonding is further supplemented by non-kin bonding, which prompted new emergent drives, status seeking, and reciprocal cooperation. These are all parts of the furry little mammal, which ramp up the reptilian drive into emotionally powerful and consciously experienced imperatives. Mind-altering substances that make us feel happy, unstressed, or powerful, or that simply numb out unwelcome conditions, can give rise to addictions for which this part of the brain plays a central role in mammals. The new mammalian, or monkey mind part of the brain, the neocortex, could be called our chatterbox, calculator, or computer brain, because it's incessantly talking to itself, fretting about the past and worrying about the future, performing rudimentary cost-benefit analyses, and computing the balance of favors and debts in each of our social relationships. It's the condition of mentally being anywhere except in the present moment. Our monkey mind has a tendency to endlessly toss up bits of thought, leaping haphazardly from one thought to the next. On the plus side, the neocortex is a fabulous tool for using symbolic language and for listening to and generating a continuous stream of information with seemingly no effort. That is, engaging in conversation. It also provides 2 functional advantages. First, there's the scenario building function. actions can be tested safely within the mind before one actually makes a choice that is tested by the world at large. Scenario building has obvious advantages, but the downside is that the process can be emotionally draining. That is, when we remain in a state of indecisiveness. Thus, a byproduct of evolutionary advance is that the new mammalian brain generates an internal source of stress capable of magnifying the external stresses that the world sends our way. Second, one has to choose between competing drives. The imperative of having to choose between multiple independent drives is what gives birth to free will. For Dowd, this understanding of evolutionary brain science demonstrates that free will is real, very real. Big-brained mammals have the capacity to consider alternatives and thus choose among the often competing reptilian and old mammalian drives. Humans, living in a world created by symbolic language, face additional dilemmas unique to our species. All the competing drives and the complexity of our lives in a civilized world can propel us into a state of incessant worry and despair. Monkey mind and furry little mammal team up in an endless loop of negativity that can escalate to disastrous ends, depression, and even suicide. To calm our hyperactive monkey mind, practices have emerged, some healthy, others not, to give us respite from this compulsion to fret about the future and revisit the past. Such practices include meditation, chanting, ecstatic dance, drumming, playing a musical instrument, reading a book, attending a symphony, attending the opera, engaging in sports, immersion in a hot tub, massage, computer games, television, mind-numbing drugs, shopping, and much, much more. Evolutionary brain science has revealed that the frontal lobes are crucial to humans to live successfully in any culture today. The frontal lobes perform the most advanced and complex functions in all of the brain, the so-called executive functions. They're linked to intentionality, purposefulness, and complex decision making. They reach significant development in humans. Arguably, they make us human. It is here in the prefrontal cortex where a new drive can emerge that is strong enough to help us choose between mammalian and reptilian drives, and to do so with less stress and far more conviction. It's here that we can create and nurture a higher purpose, or Dowd's so-called higher porpoise. A higher purpose will, of course, act in concert with some of the older drives, and it will surely change during one's life. The frontal lobes are where ideas are created, plans constructed, thoughts join with their associations to form new memories, and fleeting perceptions held in mind until they're dispatched to long-term memory or to oblivion. This brain region is the home of consciousness, the high-lit land where the production of the brain's subconscious assembly lines emerge from scrutiny. Self-awareness arises here, and emotions are transformed in this place from physical survival systems to subjective feelings. If we were to draw a "you are here" pin on the map of our mind, it is to the frontal lobes that the arrow would point. Now that we raise the subject, let's examine what we mean by consciousness. But first, a word of caution about the disagreement generated by this topic. The idea of consciousness has intrigued philosophers for centuries, but it's resisted a simple definition, even to this day. The philosopher David Chalmers has categorized more than 20,000 papers written on the subject. Nowhere in science have so many devoted so much to create so little consensus. Some philosophers doubt that a theory of consciousness is even possible. They claim that consciousness can never be explained, since an object can never understand itself. So maybe we don't even have the mental firepower to solve this perplexing question. To give you some idea of the mental swamp this topic introduces, here are 3 attempts to define consciousness. The Wikipedia definition is so broad as to be almost useless, but it does include having a sense of selfhood and the executive control system of the mind, which ties in nicely with our description of the prefrontal cortex. When physicists like Michio Kaku try to understand something, they propose a model or a simplified version that captures its essential features. Kaku has the brain creating its own model of the environment from its multiple feedback loops and then simulates it in time in order to achieve a goal. I'll give you a moment to read about it on the slide. On the other hand, the philosopher Loyal Rue contends that definitions here are pointless and unsatisfying, and that if you're conscious, you already know everything you need to know about consciousness. Rue goes on to claim that the interesting and deserving question about consciousness is not what it is, but rather how it comes to be. When we ask about the nature of consciousness, what we really want to know is about the conditions under which it occurs. The details of these conditions are still largely obscure, but there's good reason to feel confident about the general picture. Conscious experience is produced by the organized activities of the central nervous system, by the brain in particular. No brain, no consciousness. The brain functions to process neural signals. It receives input signals from upstream sensory neurons, alters and enhances them by the activities of interneurons, and then transmits output signals to downstream motor neurons. Somewhere in the process of interneuron enhancement, conscious experiences are generated. But how? Let me give you 2 descriptions. Loyal Rue says that it's useful to think about brain functions by analogy to the logic of Darwinian evolution. That is, variation shaped by selection. Consider the act of brainstorming. In brainstorming sessions, we deliberately generate a range of options for behavior. The more numerous and far-fetched, the better. This stage parallels the generation of genetic diversity in the evolutionary process. But then the brainstorming process turns to the task of evaluating options with a focus to ruling out the bad ideas, an operation analogous to natural selection. At the end of the selection process, we're left with a survival of the fittest option for behavior. In this view, the brain functions both to generate and to limit diversity among options for behavior. Rue goes on to say that the brain routinely operates as a high-speed brainstorming device. As we interact with our environment, we're under continuous demand to monitor the world and to design behaviors appropriate to it. Information from sensory systems, association systems, and long and short-term memory systems construct for us a kaleidoscopic stream of images about how things are out there in the world. Fragments of information from attention and memory are associated instantaneously to propose a broad range of guesses about how things are going. All of this activity transpires well beneath the level of conscious experience. The subconscious brain is an unpredictable storm of unresolved possibilities, both for what the organism will perceive and for how it will react. The orderliness of conscious experience emerges out of the brain's activity in generating the storm to begin with, and then inhibiting some possibilities in favor of others. Whatever is left surviving at the end of the editing process becomes the featured stuff of consciousness. As an alternative view, Professor Kaku offers what he calls a space-time theory of consciousness among species. because it emphasizes the idea that animals create a model of the world mainly in relation to space and to one another, while humans go beyond and create a model of the world in relation to time, both forward and backward. Plants have the lowest level of consciousness, termed level 0, where the organism is stationary or has limited mobility and has only a few feedback loops for a few parameters, such as temperature, moisture, and sunshine. Organisms such as reptiles that are mobile and have a limited central nervous system are deemed to have level 1 consciousness. The lizard brain has feedback loops to monitor their sense of smell, balance, touch, sight, and sound. Level 2 consciousness occurs in organisms which create a model of their place in space, but also with respect to others. In other words, they're social animals with emotions. Level 2 coincides with the formation of new structures in the brain in the form of the limbic system, which includes the hippocampus for memories, the amygdala for emotions, and the thalamus for sensory information. Kaku's model allows for hierarchies within each of these consciousness levels. For example, a wolf pack may have a higher level of social interaction than, say, a donkey, and requires more feedback loops as a result. Charles Darwin once commented, "The difference between man and the higher animals, great as it is certainly one of degree and not of kind. But what separates human consciousness from the consciousness of animals?" Kaku believes that humans are alone in the animal kingdom in understanding the concept of tomorrow. Unlike animals, we constantly ask ourselves, what if? Weeks, months, and even years into the future. And level 3 consciousness creates a model of its place in the world and then simulates it into the future by making rough predictions. By the time we reach level 3 consciousness in humans, there are so many feedback loops that we need a command center to sift through them in order to simulate the future and make a final decision. Accordingly, our brains differ from those of other animals, especially in the expanded prefrontal cortex, which allows us to imagine the future. This seems like a good point to turn to the question, what makes many humans turn to religion in their lives? And in particular, why our brains and our minds have evolved to be spiritual. I'll be looking primarily at the research work of Dr. Andrew Newberg, a neuroscientist who over the past 20 years has published extensively on brain function, brain imaging, and the study of religious and spiritual experiences. In addition to researching the historical purposes and practices of world religions, Newberg is focused on what happens in the human brain and its related systems during prayer, meditations, and mystical experiences. This slide shows some of the types of spiritual brain research that Newberg has reported, much of it done by his own team. Some of this research involves brain imaging during spiritual practices, and some of it involves subjective interviews with people who have undergone mystical or near-death experiences. Some of the research involves simulated experiences using drugs, religious symbols, or sensory deprivation, while other simulations focus on emotions such as pain relief, empathy, compassion, and forgiveness. These tests involve both brain science and neuropsychology. Even though people share a number of similar perspectives, their experiences differ. As a result, each person's interpretation of reality and of God is bound to be, to some degree, unique. Much of the research in this area is subjective because people who are studied are asked what they personally think or feel, but it helps get at the underlying neurophysiology. Ultimately, there are many ways of approaching the concept of God, including religious, theological, anthropological, sociological, philosophical, artistic, cultural, and of course neuroscientific ways, which is where I'll focus for the next few minutes. The different cognitive functions of the brain that help us to perceive the world are also important, not only in understanding basic religious ideas and behaviors, but also in understanding specific ideas about God. The holistic function of the brain involves the parietal lobes and is responsible for the sense of the oneness of God and the oneness of all things. The concept that God is a unifying force is important. Of course, the way our brain represents the outside world does not necessarily correspond with the world as it actually is. The same is true for any spiritual reality, and in particular, the same is true for God. Our interpretations are constrained by the structure and functions of the brain. In other words, we make of God what our brains allow us to make of God. Let me say that again. We make of God what our brains allow us to make of God. And each of our brains is wired a little differently as a result of our varied life experiences. The visual function of the brain allows us to envision God in a humanized manner, making God more accessible and understandable. Many people, no matter how holistically they think about God, still envision God in such a humanized manner. They think of God as a superperson, the old man with a beard in the clouds, much like Michelangelo's vision on the ceiling of the Sistine Chapel. Because our brain has specialized areas for seeing and interpreting faces, it's no surprise that we treat God to some extent like another person. By involving the brain's visual areas in the way we think about God, we're able to make God more accessible and easier for us to understand. But this process of visualization also limits what God can be for us. Brain scan studies show that conversational prayer treats God like we treat another person, activating our social areas of the brain and the parietal lobes. Our emotions tell us what is important and what is not. They will allow us to communicate effectively, and ultimately, emotions shape our beliefs. How do we think about God emotionally? In a 2006 Baylor University study about religious beliefs, emotions play an important part because some people view God in a negative emotional way, and others view God in a positive emotional way, as shown by the people in this picture. Emotions are important in how we express and understand language. In fact, we need emotions to interpret what people are saying, and we have specific brain areas that help with emotional inflections in language. Language helps us to understand religious concepts, and of course, language is a part of rituals, myths, and prayers. We have to use language to understand sacred text and to explain religion, spirituality, and God. How do we use language, and how does our language limit our understanding of God? For many, God is indescribable. This is an interesting description because it implies that a particular thought, God, cannot be relegated to any clear language. Language is crucial for our understanding of God, but it also presents specific problems because it's so difficult to describe God. Another fascinating element of different religious traditions in regard to how we act and think about God has to do with willfulness or surrender. How do we understand God's will, and do we surrender to it? The feeling of willfulness comes from the frontal lobes. Do we have free will? Do we control our thinking about God? What do we think God wants us to do in terms of our behaviors and thoughts? Is God something we should surrender ourselves to? By surrendering themselves, some individuals find a new understanding of God and a new relationship with God. The act of surrendering becomes an important way for some people to change their beliefs about God. This is particularly important in mystical practices, which I'll touch on in a moment. The brain believes that the things it perceives are real. We assign reality based on the degree to which something seems real. Why do some believe God exists and others don't? Regardless of your beliefs, it is the brain that draws a line between a belief that God does or does not exist. For example, research has shown here that there are differences in the brain scans of atheists and believers contemplating God. For atheists, the brain is not able to activate in the same way as a religious person's brain, largely because they don't have a clear sense of God's existence. The brain functions in specific ways towards self-maintenance and self-transcendence, and religion provides powerful mechanisms to accomplish those goals. The functions of religion overlap very well with the functions of the brain. Because of this, the brain is likely to hold on to religious beliefs and ideas very strongly. It would seem that religion and God are not going to go away for a very long time. The self-maintenance function of the brain is very broad. It incorporates all of the things that our brain does to help us survive, including eating, drinking, mating, and simply navigating the complex and sometimes threatening world we live in. The self-maintenance function is also the function that helps us avoid danger by enabling the flight or fight response, for example. To some degree, the abilities of this function are similar to the adaptive advantages of religion. Ultimately, a spiritual brain helps us to survive. Research on the relationship between religions and health has generally shown that religion is beneficial to our physical and mental health. In this way, religion supports the primary brain function of self-maintenance. However, this is only part of the story, because an organism doesn't merely maintain one steady, unalterable state or condition throughout life. People change, and as a result, the brain must have the ability to change and adapt as well. Self-transcendence refers to the brain's ability to do this. As we grow up and go through life, we learn new ideas and behaviors, meet new people, and continue to develop as a person. From a physiological perspective, the brain maintains a sense of self-identity even as it processes and adapts to all the changes in human life. The brain has the ability to change itself by rewiring the connections between neurons and possibly even changing the functions of neurons in a process referred to as neuroplasticity. While the brain can strengthen or weaken connections, there is a certain degree of stability within the brain and its connections. This allows us to be who we are throughout our entire lives. However, the brain also has flexibility, variability, and changeability. This allows us to transcend ourselves from one moment of life to the next. From an evolutionary perspective, we should theoretically be transcending towards something that is even more adaptive, if not actually better. But the issue is, we don't always know what is adaptive. The brain keeps trying new ideas, new beliefs, and new behaviors. Through learning and trial and error, the brain begins to figure out the best way to manage itself through life. However, it's important to realize that the brain is more interested in adaptability and surviving than in accuracy. Religion can be a powerful source of self-transcendent activity. The primary tenet of most religions is to better ourselves. Religions generally provide a system of morals, a set of practices, and a set of beliefs that we are to strive toward. This means that religion is providing a framework for change. As the brain ponders how and why to change in the future, religions, at their best, tell human beings to try to be more kind, more loving, more charitable, and to strive to do good for others. I'll conclude this presentation with a few comments on the topic of mysticism. This image is a painting of St. Francis of Assisi having a mystical experience, which may be timely given that the new Pope's identification with St. Francis. Although I've personally never had a mystical experience, the phenomenon is found in all major religions, religious traditions throughout all human time periods. The spiritual brain is capable of a wide range of perceptions and experiences, but of all these, the mystical experience is surely the most intense. At least Andrew Newberg thinks so, based on his 20 years of neuroscience research into spirituality. It's likely that there are as many definitions of mysticism as there are of consciousness, and I've chosen this definition by the philosopher and psychologist William James. The most important aspect of the mystical experience is oneness, the holistic process, but there is also the notion of peace, which is likely associated with the calming part of the autonomic nervous system. What is it about the spiritual brain that makes it capable of even conceptualizing a notion like the oneness of the cosmos? Newberg believes the answer is about love, usually regarded as an emotion, which is experienced in several areas of the brain, including the reward system in areas involved with the neurotransmitter dopamine and with the insula, which helps us perceive our emotions. Some studies suggest that during mystical experiences, the parietal lobe shuts down, or activity is sharply reduced here. This makes sense because the parietal lobe is our spatial and temporal orientation area, which would not be useful in achieving a sense of oneness with God or with ultimate reality. There are good reasons for calling the brain mystical just by looking at its physical structure. The brain works by integrating biological, psychological, social, and spiritual elements. All of these things together make us who we are. As a whole, the brain is intensely integrated. It is itself a oneness made up of billions of neurons and neural pathways to provide a generally unified view of reality. Consciousness and subjective experience are intimately tied to the biological workings of the brain, but at this point, scientists have no clear way of describing how that happens. This indescribability of how the physical brain relates to a spiritual mind is very similar to the kind of paradoxical and indefinable descriptions reported from mystical experiences. A variety of different cognitive processes are involved in much of how religious and spiritual experiences are perceived and interpreted. These experiences are converted, along with our memories, sensations, emotions, and social interactions, into a set of beliefs. The causal function of the brain is responsible for the notion that the oneness is somehow causing the material universe to come into existence. And if the experienced is perceived as God, then the mystical understanding of God is such that God caused the universe. With a holistic function, not only is the universe experienced as a oneness, but this notion can also become the prevailing tenet of a spiritual tradition, such as Buddhism. The emotional value of the brain might allow you to experience the mystical as a mixture of awe and joy. Mysticism is described by Newberg as a knowing state of the mind that involves the perception of a unitary reality, a reality in which everything is regarded as a singular oneness. There is only one object in this knowing state, so there are no relationships between multiple objects, which has a very peculiar aspect to it. There is no experience of the self. Because of this, those who experience this state have the perception of going beyond their own ego's thoughts and even beyond their own brain, which is highly contrary to the notion that the brain is what perceives our reality. When a person experiences this state, not only do they perceive it to be real when they're in it, but even when they're no longer in it, the brain keeps telling them that the experience represented the true reality. In fact, the mystical experience is usually described as being more real than every other reality experience. Up to this point, humanity seems to have taken two approaches. The scientific approach, which typically tries to reduce reality to measurable material quantities, and the spiritual approach, which seems to culminate in the mystical experience that is mostly beyond the reach of science. Maybe there's a third option. Maybe our best chance to understand reality, indeed of understanding ourselves, lies in taking an integrated approach to this problem, which allows the spiritual perspective to inform the scientific perspective, and vice versa, which in my view is what we're trying to do in this Science and Religion program. That concludes my presentation. I plan to switch the last two lectures of this module on human evolution for better continuity of the subject matter. Next week, I'll present the role of rituals in religion, and we'll follow that with the evolution of culture and religion on November the 9th. Now, do you have any questions about our topic today?
How is it that this ability to experience God has helped us in survival? Because otherwise, we wouldn't. It's got to have something to do with our ability to survive.
Well, there are probably as many answers to that as there are people in this room or people in the world. My feeling is that the understanding of the concept of God leads us into a transcendent state of becoming more than we are. And it leads us to what Dowd calls a higher purpose. It sort of presents a role model, it's kind of setting kind of crudely, but a way of living, a way of understanding, a concept of being a part of something greater than just ourselves. And so it leads us into something that is more universal. Ben, do you have thoughts on that? Others in here? It's a very good question.
That we are, that what religion, one of the functions it provides is cohesiveness in the community, which relates to, in the earliest days, continuation. You'll get into this when you talk about culture, I think, too. Survival of the group, because the group cohesiveness means that you can function better together and even overcome other groups if you have to in war, etc. So you survive that way. That's part of it. That's not all of it, but that's part of it. One issue.
Thank you for this very rich presentation this morning. I really enjoyed it. Just want to make everybody else aware of some complementary materials. They deal less with religion and more on the science of evolution, and that is, it's a TED Talk called Big History by David Christian. It's also, Big History is also part of the teaching company, Great Courses on Tape, and that's where Bill Gates learned about it and popularized it. And it's my understanding he's even funded a website on Big History. So I would consider that a valuable source of information that complements what you're teaching. Also, I want to take the opportunity to engage a little bit of speculative theology here based upon your presentation. And that speculative theology is, there's this pantheistic understanding of God. God has a transcendent and immanent nature, and God created humans in His image. And we know that through the science of evolution, the emergent, or the scientific principle of emergence, and that is the whole is greater than the sum of its parts. So this leads me to speculate that consciousness, God has the transcendent and immanent nature. Consciousness could be the transcendent nature of humans, and that, moreover, this mystic experience could be the consciousness of humans in communication with the consciousness of God, or in other words, the transcendent nature of both man and God in communication. Just something to think about.
Okay. On this point about the DVD, the great courses by David Christian, I got that DVD back in 2012 for the series we did 2 years ago, and it is excellent. I highly recommend it, and it's very, very well done.
I like what you said. I don't know if this was a quote, but we make of God what our brains allow us to think of God.
Yeah.
And I think that's why the understanding of God as developed by Saint Anselm is so terrific, because it's not limiting. God is that of which none greater can be conceived. So it doesn't limit God. It frees our imagination without limitation in how we think about God.
Brian, the other point on that I was trying to make was that our brains are all wired a little bit differently, because we've all had different set of experiences in our lives, and they develop differently. And because of that, we think about God. We should expect to think about God somewhat differently, because as much as we think we're all alike, we're not alike, because our brains are not alike. We haven't lived the same lives, and that gives us a different kind of perspective on issues like what is our perception of God, what is our understanding of God. Other questions? Philip.
I've got two quotes that I think are relevant. And I already forgot what one of them was. But it's G.K. Chesterton who said, "The proof of God is we need him so much." And I forgot the other one, but it was really good.
All right, if you transcend yourself and think of that other one, get back to us here.
I've only been able to, I don't know if it was mysticism. There have been a couple of times that I think, I read a book about the diminishment of ego also, and I think that relates to this same sort of experience of transcendence. But I think that is such an amazing challenge, is to be able to quiet the brain enough to be capable of receiving rather than constantly asking and forming in sort of conscious words and phrases what we need, what we want God to do for us, but rather the difficulty. And I think, through work, and that's probably what meditation practices and discipline certainly afford us, is the opportunity then for a mystical or transcendent experience. But boy, especially in Western civilization, the idea of calming one's brain enough to be able to do that is worth the challenge, I'm sure.
Those of you who have thought about this or experienced this, do you see or do you understand that meditation is a step into a mystical experience? Is it, or it seems to me that sort of a mystical experience is sort of an ultimate meditation event, but I'm not quite sure that's right, since I've never had that kind of an experience. Richard. Go ahead.
Well, the great mystics, Jacques Burma, that Paul Tillich loves so much, they don't necessarily meditate. It happens. It's spontaneous. It can't be programmed, worked up to, and that sort of thing. It's a revelation or a gift
So it's
or
an involuntary
experience.
experience?
For most of the great mystics, yes. And as I said, probably the greatest mystic in the West is Jakob Burma. And his experience was simply gazing at a pewter glass dish, and then had this experience of seeing through the universe. And as I said, Paul Tillich was immensely attracted to his experience. So they're not, meditation may be a way towards it, but the great St. John of the Cross and Mother Teresa, they were not necessarily brought about by meditation. But stilling the brain is, the brain does, and the ego have to be some way put aside for that experience.
Ernie?
Yeah, I just wanted to speak to the answer to your question. I think the Buddhist idea of meditation is to calm the mind, to reduce the ego, to get beyond the ego, to get past the ego, and to the eventual idea is to learn to live in the moment without the brain constantly chattering you into the future or the past, but rather it's more of a becoming in touch with the quiet of the mind, which is impossible to do in the culture we live in today. I don't think so much it's a voyage toward mysticism or mystical experience at all. I think it's more of a calming, quieting process.
The meditation is.
Meditation, yes.
Okay.
Let me mention that we'll come back to this in the last 3 lectures and
Okay.
other kind of perspectives too.
Okay.
I just wanted to
One
say,
last question.
a few weeks ago, I spent a week in Chicago with Eben Alexander, the neurosurgeon who had the near-death experience and has written a book, I think an unfortunate title, The Proof of Heaven. But his theory is that consciousness creates the brain, and the brain is a reducing valve for God, cosmic, Buddha, whatever consciousness you want to call ultimate. And that the brain is not causative, it's expressive. It's like a transformer on a high line that reduces the power of awareness, being, life. And he is more absolutely convinced what he experienced, as you said so well, is what he experienced was a lot more real than
true
his
reality.
day-to-day life.
Yeah.
And it was the most inspiring thing I've ever been around, I think. He and Elizabeth Kubler-Ross talking about their experiences of the oneness. So,
Okay.
a very different view than the empirical, but
That's not what you're saying. That's not what I heard in what you're saying. The, sort of, this is creating the brain seems the opposite of your lecture. Is it?
yes.
Seems the opposite.
Well, it's a different perspective.
Can I make yeah, I think what we're seeing is this argument that I have with some friends that I had back in Birmingham. Does the dopamine and serotonin in this experience create the ideas of God, or does God speak through this whole process and create the dopamine and serotonin actions? So that's an ongoing discussion that will never be solved, but I think that's what we're into right here.
Well, except even Alexander would say he has empirical evidence because his cortex was flatlined. He had brain scans to show how during his week of unconsciousness, the cortex was not functioning, and the part of the brain that could generate these experiences was not available. It was full of pus, as he says.
But you realize a lot of neuroscientists have a big problem with that.
Absolutely.
We've run out of time, folks. Let's adjourn. We're getting into some heavy stuff here. So, to be continued next week.
Oh, boy.
Thank you. Yeah, thank you.